Hi guys, and welcome back to the channel. Few weeks passed from my last video. I went in vacation, and after I work here in the shop I make some changes. So now today I want to do a lathe tool high gauge. I will show you what I want to do. I take here just a simple sketch. I don't need a drawing, you know. And I will adjust the dimension on the way. This is the situation. I will make a stainless steel base. I will cut here, and there I will use this stainless steel ground bar that will be placed here. And after I will make this adjustable setting here, something similar to that, you know, that we can adjust the height. And between these two parts I will make also a ring, this one, that with a screw I can tie it like this. The dimension will remain fixed here. And this one we can turn this one like this. When we put on the lathe, we can find easily the different direction for the tool, you know. And now let's go. This is also the first time that I will use the lathe after the restoration. Okay. And now we start to square this block. Let's go. Wow. It's a real pleasure to work with this machine, my friend. So, now I will square the block. See you later. At this stage we have to cut the side. I put here a carbide 12mm end mill. And let's calculate the feed and speed for the stainless steel. I will use this application, Little Machine Shop. It's simple and fast. Let's do in this way. So here we will put stainless steel, millimeter, milling, cutting speed we have to put here blank, and mill diameter 12mm, cutting edge 4, let's calculate. So I have to put a cutting speed of 46 millimeter by minutes and a spindle speed of 1200 rpm. Let's set up the machine. Because this one is the boring head, I will put here this selector on the upper position, because here is 1:1 to the machine speed control. And this one is you have to multiply by 3.3, 1246. Let's put here 1200. $1,250, this is fine. And here let's put 46. I don't have 46, but I have 50, so let's put 50. I place here now a corner radius end mill. The ray is 3 millimeter. Now let's center the end mill. We have to touch up here. I will use a piece of paper that is 10 okay, and we don't have to touch this position, because I want to do whole here the perimeter. Now let's go here, let's put this one back at 0. Let's check 1 minute. Okay, now let's plunge down 1.5 millimeter, but for the moment 1 millimeter, because I want to place here the 0. Okay, this is 0, and now let's go out, let's go at 1.5 in high, turn here, let's plunge inside 1.5. I make a mistake. Always, you know. The problem was that I plunged down on the x-axis 1.5 millimeter. That was the mistake. Now I will come back at 0, and because I did half ray, I hope that we can solve here the situation. Let's see. I'm not sure. I want to put higher speed, same feed rate. Maybe it's safe. Let me see. Still not. We need to, after, to put again the end mill and lower this phase here. Let's go a 5 deep now, and let's see if in this way we solve what I did. Okay, let's try. See you later. We are on the money here. Let me see. Nice. We are on the money. Oh yes. Perfect. Now we go to this other side. But before, I want to take this dimension. Let me take. This 19.74 plus the diameter of the mill, that is 12, 31.74, okay, minus 6, 25.74, and we should be set. Now and let's go. See you later. Now little by little, we will do it. Let's check. Nice. And now let's finish here. Perfect. Nice. Now I have to the burr. Came quite nice. So let's go forward. And now it's time to center this one, and we need to make an hole, precise hole. I think that I will bore or I will use a reamer. I need to think about in order to press down in a press fit this bar. So let's here we should it's perfect. Now I put 0. Let's go on this side and Let's do half. Half. Perfect. And here we have our 0. Nice. This one is 3 millimeter, so I will go 3 millimeter inside, and we will place over the edge. Nice. First I will make a through hole, and I will use a carbide drill bit. I also place the hydraulic chuck here, that this will be let's center first. Okay. 13 millimeter. Yeah, I think that is the right. Where is? Yeah, maybe 13.5. 13 millimeter is fine. Okay. Stop. Okay. And now let's take this one. Yeah, well, it will be a through hole, this one. Like this, in case I have to remove one day this one, I can plunge from the bottom. What dimension is this? 6. And the other one was? I don't remember. This one was 5. Yep. Let's take this one. This chuck make the life more easy, you know. Okay. Okay. Now I will use a 4-flute end mill to open at 8 millimeter. Now I will enlarge at 10. Now let's remove this one and also that one. Nice. And check the dimension with this internal mic. 10.05. It's tricky like this, because I cannot remove. Anyway, get it smaller. Here is wider. And not too much in truth. 10.05. Now we have two options. Or we try to ream at 10.5, or we will bore. Now let's place this one, and we will ream. I decide to ream here the hole, so now let's I will use the water and not the oil because I want a tight fit. So let's go. We are almost there, few millimeters. 15, 16, 17. We are almost there. I will go by hand now. Okay, we touch. Come nice. Wow, nice. Now should be 10.5. Let's check again with the micrometer. Now I want to absorb this water because I don't want this water around. Okay. Look beautiful. We remove the reamer and we will check. I place the micrometer at 10. And this 10 and 44. A little bit less than 10 millimeters, than 10.5. And here is 10.42. Okay, this is. Now we chamfer here and it's done. Okay, I chamfer and now it's time to remove this one and make here 2 holes for the magnets. It's nice, right? I don't know if you can see inside, but came very almost perfect, you know. Okay. Okay, now let's come back here. We have to put this one inside in a tight fit, not too tight, but anyway should be firm. Let's take those dimensions for the moment. 1396, 13.96 the diameter, and this one is 10. We are before the half. 47. The 0 is a little bit passing the second line. And here the third line is aligned with this other one. So 10.473. Let's go to the lathe. Now, before to make here the nice this tool is fantastic. Zero. Now I want to make here an M5. Now from here we have to go inside 15 millimeter. Now let's find out the isometric limit and fits, you know. In the left page of the black book we have a clearance, fit, and in the right page transition and interference. So now our hole is 10.5. 10.5. Following this we can follow H7, H6 on the shaft. This means that I have to do the shaft 11 micron smaller than the hole. For instance, our 10.473 is our 0 here. Otherwise, if we go to this other page for a more transition fit, I should make the shaft 1 micron bigger than the hole. But this is more than this is a press fit, you know. We have also to consider that the hole and the shaft are never 100% precise. So we need to get to the dimension step by step. Let's go. Because we are half millimeter from the nominal size, we will do only 2 passes, you know. The second one will be the finishing. At the moment we are at 11. Now let's check this dimension. We are at 10.75. $10.726. We have to reach 10.462. Let's go. I hope that okay, and now let's go out. Perfect. Beautiful finishing. $10.505. Now we are here with 10.509 minus 11 micron is 10.527. We are at 10.509, so we are in between these two, from 6 to 10 and 10 to 18. If I do minus 09 micron, I should reach 10.462. Minus 9, yes. 10.5. We are exactly here. So we are on the money. Let's try. I take again the dimension is 10.499. I think that is perfect. Now let's give a little chamfer in order to make more easy the not too much. Nice. Cretex. Let's put this one like this, we will cover the nice. Nice. I position this here again on the mill because we have to do the countersink for this one. And this is done. Now we have to make here 2 or 3 slots for the magnets. One here, one here, or I think 4 is more than enough. Unfortunately here I lost the audio, but anyway, now we are centering the 4 hole. After that we will plunge down with a hand mill of 8 mm. We will finish all the 4 holes and we are almost done, and this here. Unfortunately, almost at the end of the part 1 I lost the audio, but it's okay. I make the 4 hole here, and I place the magnets. So now we are ready to put inside the column. Let's go. So guys, before this video will end, remember to put a like and subscribe, and because for the channel is very important, I put a lot of effort, and if you can also super thanks will be very appreciated. You know, it's very hard sometimes to push going, and everything here costs, you know, so an help will be very appreciated. So let's come back to the work. Now is the time to place inside our column. I will put some oil. Okay. I will use this one with the washer because I don't have the... Even this one is too short. Come on, man. Okay. It's going inside very nice. Yeah. I think that we are on the money, guys, finally. Yes, because that one is the chamfer. Let me see. I don't want to break the screw, eh? It's fine. Here. Now this one. Everything come through. The fit was very nice. Beautiful. And here we are. Came very nice, right? For the moment I'm quite happy. And next time we will place here adjustable gauge in order to set up the tool on the lathe. It's nice and shiny. Thank you for watching me. Please put a like and subscribe, and if you can, put a super thanks. Thank you. See you the next one.